Millennium power millennium. Millennium power millennium. Universe is our Kalka. Millennium power millennium. Good morning. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, March 31st, 2022, Thursday, and this is last day of this month. And of course, the last day of this financial year. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक मार्च 31, 2022, बृहस्पतिवार 3:28 सुबह के 3:58 AM, and this is last day of this month as well as of this financial year. Of course, you know, title of talk is same as as I said beginning was title of talk, and that is real quality, coordination, engineering projects works, reliable engineers, power of communication, concrete specifications, civil engineering, contracts, safety, health, environment, designs, methods, disputed claims, parties, etc., etc. Miscellaneous list of titles, and we have to deal with this for this talk. And here is my and communication as well as engineering. These are very important topics. I did not find abundance of coordination issues on the internet. I tried many times. Even quality issues are not very abundant except quality system. And quality is an important issue along with coordination goes on. And coordination is not available in plenty. And I think people do not practice coordination, or if they practice, they don't expose it to others, and that's the reason it's not available. And you can see my this board, and also you can see my certification of international professional engineer, international professional engineer. I international professional engineers in India, and this is chartered engineer India, as well as this is fellow membership of Institute of Engineers, and that is Institution of Engineers here. Fellow membership means highest degree, highest membership of corporate level. And here is my real quality and real coordination. You can call it quality file, as well as you can say that this is my coordination file, reliable coordination. And you may say that this is my specifications file of concrete. And for time being closing chartered engineer file, and closing fellow membership file, and now keeping others open. And this is the real quality and real coordination file. This file, though it's not this is my prepared file, it's not from some source, there's no reference except my own ideas. I keep it every day, or sometimes I update it, sometimes I don't. It depends upon mine, means what I think it should be or I think should not be. It's something like that, means we have to bear with all this, we have to understand all this. You can say real quality and real coordination I am asking for. It's not imaginary, it means that we have to be together with that. We have to understand that together, and particularly being an engineer is my duty. I'm talking about Bharat India, and this is Bharat India speaks about me. Bharat, my country, Bharat India. Bharat, for international, I say Bharat is Indian name or our local name, while India is the international name. Bharat India speaks about. So I'm speaking for all, but here I'm very much concerned about my country, because my country is lacking a lot as far as general quality is concerned, special quality is concerned, engineering quality is concerned, or you can say life quality is concerned. Life quality does not mean that we should have good clothes or good housing or like that. That's not. That is living standard. I'm not talking of living standards. Just keep in mind. I'm talking of working standards. I'm talking of individual standards. I'm talking of equipment and material standards, and standards of thinking. In fact, what do you think about? Thinking is a very important part. Concentration, thinking, coordination, quality. All these are linked together. And if we don't link together, we make mistake. We don't have a job. In fact, in that case. And that's really, you can say it's different in that case. One may accept, one may not accept, but it happens that time. You cannot lead life without public engineering, without civil engineering, without engineering that's involved with everybody. And we use this at every location in our life, but every day wherever we go, but all over the world, we'll find civil engineering. It's a requirement of everybody, without which nothing can happen. And safety, health, environment is on top. It should be involved everywhere it's involved. We should take care of that as well as designs. Without design, nothing is possible. We have to, even if it's not even done on paper, it's done in mind. And how we have to do something, and that's called methods, and we have to think of methods. Party one is that person who pays, and party two is that person who is a contractor, generally call it. So both are on contract, and both should be, one has to pay, contract to pay, and other one is contract to work. So both are contractors, so generally we call the contracts one. Which moves as something else. You cannot say this is fixed on for that. It depends upon activity, it depends upon nature of work, it depends upon. There can be variations in descriptions, and there can be variations in job, and there can be descriptions in project, and of course time. So as I'm talking of quality, and I'm talking of this as well, as you can say, Bharat, India speaks, and we say we speak. Of course, we speak because we should speak, and it's not because our country speaks. Everybody speaks, and I know everybody is interested in good work. But why is if everybody is interested in good work, why it doesn't happen? Why does it not happen? And that's the point. And that's why I say real quality and real coordination. We have to think about. That's why title is real quality. Simply I should have written title quality also as I started in. But I think real quality is more important. But this indicates practicality. This indicates reality. Means it's not simply statement. It means that we have to comply with and compliance to whatever we can do, and that's called real one. It can be 50%, it can be 100%, it can be more than 100%, or it depends on what level of work we do. And same way happens in coordination. Coordination is right time, before time, or it's done after work is done. That's no meaning. Of course, it's meaningless. But real quality and real coordination we have to think about. Not only to think about, to practice about, and that's what you and I get up for real quality. Are we sleeping or we are sleeping? We have been sleeping. It depends on your thinking. If I have been sleeping or you have been sleeping, then we have to get up and think of real quality. And if you can make real quality, means you and I get up for reliable coordination. And if you want to achieve quality, we have to depend on reliable coordination. The coordination, that is a must, and that cannot be avoided. And if you don't do that, we say, okay, I've done just for sake of formality. If I say that formality cannot work, that you and I get up for reliable coordination, everyone stops sleeping in our country. And of course, I am concerned with that. I can say to my country, because I know other countries don't sleep that level. Some countries maybe, but generally only our country is a relaxed country. We don't care about our country. We don't care about future. We are not people very seriously involved in work. We just do time pass. We are interested in other issues rather than quality and coordination generally happen all the time. I've never seen seriousness, degree of seriousness in our country, except we are very serious about religious matters, we are very serious about other matters, which don't have any link to work, which don't have any reliability to life. We don't realize that we waste our time sometimes. We waste our times in many issues which can be avoided. That's why we cannot reach scientifically or engineering to that matter. And even those who are very highly educated engineers or other professionals, they also count their value in terms of degrees. Otherwise, they don't count in terms of experience, in terms of achievements, in terms of that. And that is one of the reasons that we fall behind many others. Seriousness is very low level. You can say why, I don't know reason for that, but degree of seriousness is not considered. You cannot say that. What I say must be committed, must be delivered at the same time. We take it easy, and of course easy going on to work, and we say quality and coordination is a very important issue for us because we are sleeping. Everyone stop sleeping in our country, in our I can say quality and coordination, and be my and everybody's friend. And that's why I say I'm asking quality and asking coordination. You have to be my and everybody's friends. But I know quality and coordination are not entities. They can't listen to what I'm saying, and that's why it's very important to be very serious about this matter. If I'm not serious, I can't do anything. And that's why this title is different, and I can say yes, it is. So I can say I and other cannot satisfy. And if you don't exist, without you both remain, we are all friends together for all others. Demanded quality, or we can say whatever is a demand on work, that is demanded quality or required quality. You can say both words can be used, demand or required. Demanded quality, we cannot leave otherwise. You cannot leave us, you cannot leave me, because you are my destiny for nation, for Bharat, for India. Want to go, we don't want you go there. No, you don't go there. Yes, we require you permanent statement here, permanent stay here. We require to establish both remains permanently in engineering profession and also other walks of life, because engineering profession means development, it means advancement, it means standards, it means requirements, it means meeting requirements, it means maintenance, it means manufacturing, it means production, it means whatever is involved in terms of economical development. And that's we call every country's economy also. And due to that reason, engineering is industry, engineering is work, engineering is thinking, engineering is whatever. Life itself is a part of engineering. Engineering is a part of life. You can say mutually together they are to one. Without reciprocation of engineering, life cannot work, and without reciprocation of life, engineering cannot work. Have active quality performing applications. Quality is sufficient is a real quality engineering and reliable coordination engineering approach on working designs, a must. Manufacturing and construction procedures, a must. Continuously to do assessment for working considerations for quality goals in all works, and fix real quality in Bharat, India. Come what may, that's an important point. We have to fix quality in our country, Bharat, India. Whatever may happen, we should not bother. To stick to that, we must reach a goal that this is required, and that's a very important point. Fix real quality in Bharat, India. And if we cannot fix, then we waste our time. We cannot do anything. The time goes away, it doesn't come back. That is money. If it goes away, it cannot come back on its own. You have to earn more money, or you can say it's like money. Quality is like money, permanent money. Money once lost can be brought back by by some work, but if quality goes away, it is like a chemical change. It cannot come back. Real quality, you may say quality is a change, permanent change. If you do good work remains. If you do bad work, then bad work remains. Fix real quality in our country, Bharat, India. Come what may, and that's important point. It's not daily statement, it's a specific statement I make every day, but I don't know how many people realize about this. There can be no excuse for any concessions. I don't want to give any concessions. You should not also give any concessions on part of quality because of quality. You should not accept bad work. That's first requirement. If you accept bad work, means okay, sometimes you accept worse. If you are frequent in accepting that, this means you are not serious about quality, and quality shall not be serious with you because of your developed habit of accepting everything. Okay, sometimes in emergency something can be accepted, but it cannot be made a practice. Quality is a requirement, you should not forget. It's not a simply smiling talk, it's a requirement, and quality should be in work. It should be seen, quality in every sphere of life should be seen. But engineering, it's a mandated requirement. In engineering, if you don't give quality, means you fight with yourself, you fight with your society. Why don't you? Because society cannot understand you are not giving quality, but it is sin. You can say you are paid for that. If you don't do that, means you are not doing your job, you are not doing engineering. You may be happy that I'm running or somebody is running behalf of me. I am in this company and I'm working for this. I have very good relations with employer. I have very good relations with everybody, but you have no relations with quality. This means you don't have any relation to anyone. Works quality cannot be compromised. Of course, we should not have works quality cannot be compromised. It can never be, and therefore we do not intend to compromise. Just in name of fragile. Quality system may fail. Of course, we have systems, ISO 9000, or we have Sigma, we have many others. Likewise, these systems are human made. These systems are not natural made. These are not materials. These are not having any properties except what we have framed them. And we comply with that whatever we have framed. But these do not guarantee any compliance to quality if you do not want to do that. These do not work automatically. Quality system may fail, but works quality must perform and it must be delivered. Whereas it doesn't happen currently in our country, at least in entire scenario in ours, Bharat, India, and therefore I can say preliminary considerations. Where does real demanded quality exist? That is a question. Where does real demanded quality exist? And I can say nowhere generally. Answer is that, and unsuccessful to find anywhere unfurnished. If you do not conduct, that's why I say unknown is its conduct. It cannot conduct on its own. We have to be there, otherwise it cannot exist. To quality means individuality. When we work in groups, every individual in that group must be quality oriented, coordination oriented. Only then we can say it can be done. And if yes, then how to do it? And that is a point. Can we bring working environment to quality? I mean to say to quality level. And that can be done only if coordination levels are acceptable, coordination levels work, and these provide supports. Certain red lines that must be turned green, and that must is a must. You can entitle like that, or you can indicate such that these are red lines, and particularly I put it red just to remove it from red to green. Certain red lines that must be turned green, and that must is a must. What are those? We brief it only, it's not explanatory, just for your information, because these go on changing from time to time. What comes to mind, or if I get some suggestion, I can think, I can look into that again and again. Can we know, this is the point, can we know and apply product and work quality standards? Can we know and apply product and work quality standards complied with overseas, for example, in Gulf Cooperation Council countries, on buildings and on plants facilities? That can be one consideration. One point that we have to compare with someone. I'm not stating that quality is best there, but we can compare. Maybe it is far better than ours, because money is not stopped there, money is not restricted there. Per my experience, understanding, I experienced for decade, 2 decades about those countries, and that's why I am inclined to think of that. I'm not saying what I'm saying is right. Many of you might have worked there, so you know better than me. Maybe I'm wrong, but quality cannot be wrong. That's the point. We can say, can we work on required coordination? And that's the point. Can we work on required coordination activities to achieve defined or expected quality profile on works? Can we work on the required coordination activities to achieve defined or expected quality profile on works? That's another point. And we can say, can we work on required coordination activities to achieve defined or expected quality profile on works? Why we should not revisit quality required specifications and update per world working standards requirements? Why should we not apply coordination requirements? And then, is it not a must reliable solution? That's the point. The state of quality of works, and how to improve such mandated works quality to certain minimum required marks. Really, we have certainly worsening state of quality of works, and how to improve such mandated works quality to certain minimum required marks, at least to match with minimum international requirements. Should we not force ourselves to work on coordination in each activity? Should we not force ourselves to work on coordination in each activity? Worsening state of quality of concrete, and how to improve such mandated quality to certain minimum required marks. Concrete component in construction amounts to major percentage. Concrete components in construction amounts to major percentage of cost, and therefore it becomes incumbent on us to care about quality of such component. It's of course out of common and professional understanding about why we do have no seriousness in this regard. Worsening state of communication and coordination. Worsening state in engineering. There is no one society. There is a long list of societies in engineering. Are we engineering force or incapable lot? And that's the question. Are we engineering force or incapable lot? And we are big people. When shall we awaken ourselves? Shall some time come or no time comes? Shall we transform existing engineering strength into standard quality working force? Who shall decide about all such questions that are being faced with current? For this talk, this is limited talk, and sometimes I take this point, sometimes I take that point. So I should say, engineering detailed deliberations must be information must be brought to those personnel who require it, and it must be provided in right time for right requirement, and quite rightly duly coordinated. So there is long meaning in this. Information must be brought to those personnel who require it, and it must be provided in right time for right requirement, and quite rightly duly coordinated. So it means personnel, those personnel. What does it mean? Information must be brought to those personnel who require it, and who are those? Those personnel who work on front. It may be manufacturing unit, it may be some industrial processing unit, or it may be construction. Those personnel who are on line, front line, to whom in medical we say warriors, but here we say prosecutors. In fact, they work in front and they expose themselves to all dangers of safety, or you can say dangers in work, and they are called frontline workers or line managers, line workers. Information must be provided to them, and that should be provided in right time, not after time or after work is over. Before work is over, with sufficient time given to understand what is to be done, and for right requirement and not misleading requirement. For what it is required, for what they work, that information should relate to that. And quite rightly, duly coordinated, that's the meaning of coordination, that if there are so many activities involved, if there are so works are involved, so items are involved, each item should speak to other items in a proper way, and not dissemination of engineering information. This dissemination is very big word, which means there is no limit. Your information can reach whosoever requires it. There should be network, there should be that process, there should be that, you know, system, that your information should reach everywhere. And now, because communication is not very difficult, network is there, all facilities are there, and there should be no question that information cannot be disseminated intensively. Though it can be disseminated excessively, there's no problem. But dissemination of engineering information about quality requirement is not available, and that's very important. Dissemination about coordination is not available. That should be provided. Quality may be known to only those who are professionals, but quality should also be known to those who are honors. It should be known to all stakeholders. In it, I cannot say in details, but to some requirement. So quality requirement should be known to everyone, and how to transform using method statements, and that's particularly for those who work online, on the work in front, who deal with works. They should know what they are going to do, otherwise there's no meaning. Method statement doesn't mean that it should stay in your books or files. It should be studied, and it should be applied. That's the real meaning of that. that is a kind of concentration from everywhere, how to use workers, how to use machines, how to use all the resources, and how to relate it to all parameters which are required. And that's called concentration on construction method decision making, and that should be done prior to the method is finalized. And everybody should be involved with that, who works on sites or in factories, who works on decision making and who works on providing resources. And that's what it says, a resolution to do right work per specified requirements, and that's what's involved in this specified requirement. So you can say methods can be designed and drawn at every possible and convenient stage. No work can be no work be carried out without reference to method statements, which must contain SHE and quality approach at every possible convenient stage. What about contracts for construction? That is an issue. Should engineers know thoroughly what about contracts for construction? And that's a point here. What about contracts of construction? What about contracts for designs, procurement, and construction? Should engineers know thoroughly? Do we organize to design quality contract? Do we organize to design quality contract, or do we go per lines decided by contracts on works, quality performance that contracts can attack on designs and prosecution? Do our engineers have interest in contract design, drawings activities, which always remains very complex and certain the impact on contract performance and contract related disputes? Involved with construction activities, and if not, what are valid reasons? There are valid reasons. So sorry, gentlemen. What about mathematics? So our engineers, those interested in design activities, not are our engineers those interested in designs activities not inclined to involve with construction activities, and if not, what are valid reasons? What is the issue that engineers do not incline to work in coordination? And that's the point. What is the issue involved that engineers are not inclined or do not inclined to work in coordination activities that impact on quality of designs and quality of construction? Should we respect project contracts, or we should move without such contracts? What about major materials being concrete in structure? Often permanently included in structures and buildings everywhere on all projects. What about engineering materials being used to produce various hundreds parts goods in manufacturing? And what is provisions by government to force productions and construction be delivered with quality compliance? What can be certain reason that quality requirements being ignored by a nation? And what reason does exist that engineers are not able to conduct required contributory tools towards quality? How can quality be controlled and systems work out? So we can say that how can we quality control? That's a question mark. How can it be controlled, and where to see? It's very important to understand this point. How can quality be controlled? We cannot leave it for others to decide how can control. How can quality be controlled and system work out for past organizations in this regard? That's the point here. I have to understand this point very well. What that point is now. Now we are moving in different way, in different phase for this. And this is what should be role of actively performing workers to handle instructions in this regard. What should be required active role of engineers in branches of engineering. How can quality be controlled and system worked out for past organizations in this regard? What is the engineers are not able to conduct required contributory roles towards quality domain? What can be certain reason that quality requirements being ignored by nation? What's provision by government of force to force productions and constructions be delivered with quality compliance? Now these are very big questions which we must find answers. What should be the role of actively performing workers to handle instruction in this regard, and these are linked to what should be required active role of engineers in all branches of engineering, because on projects all branches are involved. It's not simply one branch or two branch, one branch or two branch. How can quality be controlled and systems are taught for best organizations in this regard? Is quality compliance requirement so difficult that professionals ignore it, or they remain under pressure? This is the main point. This is really a point that we should think of how it is that we don't care for this. Is quality compliance requirement so difficult that professionals ignore it, or they remain under pressure? Can we people digest bad quality in goods, products, or in construction? Can we digest that? And what's the role of government? So leave all that. Now going to jump onto, we'll take remaining points elsewhere sometimes. And now we go on to reliable coordination, engineering projects, public engineers. And this is समन्वय अभियंत्री योजनाएं में अभियंताएं सार्वजनिक reliable quality engineering workers, works and reliable coordination engineering, a professional engineering, and this is not for everybody, and which is what I should say. And that's missing real coordination means missing good engineering. That point you have to understand. Missing real coordination means missing good engineering, and it is very important point. We cannot leave it otherwise. How is not missing, and this means it says when a question is coordination engineering a must for everyone. This question is coordination engineering a must on every project? And answer you know very well. And project means all performance activities or performable activities involved, from pre-designs to final completion of complete construction. Few difficult questions to be answered by engineering community, and these answer questions very easy in community, and that is regarding quality and coordination, respective involvements in entirety. Can we ignore these domains? And that's we have to see what do we engineers think our issues as mentioned. How many of us to conduct quality and coordination requirement? That we have to ask ourselves. Is it not right time to contemplate and deliberate on this subject? I think always time is right. Every time is right. There is no question this time or that time. But this time it's right because we are missing something, and that's called quality. Can good and just and that is standard specifications. We are moving on this right last time, and we were some page, I don't know which page it was. It was a slump we had gone through. We had gone through slump, and we had also gone through values of minimum slump for various structures, and even then sitting on in this portion of columns, that was you can say effective amount of steel in concrete cover zone, this amount of steel per unit volume in religious regions shown below, and that you can see we study here for considering effective equivalent amount of steel in concrete cover zone, this amount of steel per unit volume in required zone, and that's why you say that's what we say calculation zone for, this is this one is calculation zone for effective equivalent amount of steel for single layer reinforcement, and here this is dotted one. So calculation zone for effective equivalent amount of steel for multi-layer reinforcement, and that is this one. And of course this is distance from concrete surface to center of main reinforcing bars, and that is this distance. This is hoop, or you may say this is ring. In general, main reinforcing bars are these circles, main reinforcing bars, and intermediate hoop are these. This is main reinforcing bars, and this is, you can say, hoop. This is intermediate hoop. This term is now it's up to means you can say. Now what it says, typical values of minimum slump for concrete placement of beams. In this case it is said compaction height is given, minimum steel precision is given, and also you can say compaction height means from where you compact, the distance to compaction distance. If you have vibrator means nozzle of vibrator, this difference between nozzle of vibrator location and from where you use your vibrator, and that is called location of vibrator. Vertically it's called compaction height, and which may be less than 5 meter, which will be between 5 meter and 1.5 meter, and which may be between 1.5 meter above, and depending upon that various slumps are indicated here. And it also steel spacing dependent, 150 mm spacing or more is 100, or 150 means more spacing or less spacing. Less spacing means more, you can say more slump, depending, because the concrete should go into every part of space in which you pour or you fill. Examples of members for which different compaction heights are used. You say less than 0.5 meter small beams, less than 0.5 meters and compaction height, and 0.5 meter to less than 1.5 meter standard beams, and it is 1.5 meter more deep beams. So these three levels of beams, the small beams, the standard beams, and deep beams. Minimum slump for placement is selected according to whether it can be judged that adequate compaction can be done by inserting bar-shaped vibrators above 40 mm in diameter. Minimum slump for placement is selected according to whether it can be judged that adequate compaction can be done by inserting bar-shaped vibrators about 40 mm in diameter. If it is just that adequate compaction can be done, a minimum slump for placement is 14 cm is used. If it is judged that adequate compaction cannot be done, high fluidity concrete is used. So what is this? If it is compaction can be done by inserting bar-shaped vibrators about 40 mm in diameter, 40 mm is not more 1.5 inch, about that's okay. Natural, this is not even 40 mm. If it just adequate compaction can be done, a minimum slump for placement of 14 centimeter is used, and you can say minimum slump, that is 14 centimeter. If it is just that adequate compaction cannot be done, high fluidity concrete is used. If slump exceeds 21 centimeter, high fluidity concrete should be used in order to achieve required segregation resistance and place concrete widely. Table values minimum slump for concrete placement of walls. It is first is amount of steel, minimum steel spacing, in compaction height 3 meters, 3.5 meters, and 5 meters or more, and less than 200 kilogram per cubic meter is steel, and in the other case 200 kilogram to 350 kilogram per meter cube, and then 350 kilogram wow. In first case, when it's 200 kilogram per cubic meter, minimum steel spacing is 100 mm or more, or less than 100 mm, and then like you can say in first height smaller wall it may be 8 mm because it's closer steel, 8 mm. In next one, that is 3 to 5 meter, 10 mm, and more is 15 mm, and less than 100 mm spacing is 10, 12 and 15, like that, very common is 10, 12 and 15, 12, 12, 15, and it goes on increasing when it's 350 kilo. More steel means more slump, and middle level steel means middle level slump, and if it is less than 200 kilogram means spacing is more, you can say. It depends on. So more steel means more slump, less steel means less. This is a proportional way. I am not saying you stick to it like that. Typical values of minimum slump for concrete placement of pre-stressed concrete members. Type of structure, average amount of reinforced steel, design strength of concrete, minimum slump of placement. So here is type of structure: girder of pre-stressed concrete, superstructure, tension mainly with internal tendons. Then there's another one, there's cross beams and unsupported floor, slabs of a T-girder bridge, unsupported floor slabs other than those mentioned above, members including densely reinforced regions. In this case, various cases are here. Average amount of reinforcing steel less than 120 kilogram per cubic meter to 1 to 250 kilogram per meter cube, then 120 to 140 kilogram reinforced concrete equivalent, and about 250 to 300. Likewise, it goes on increasing from 300 to 50. Then likewise, various cases are here, and you can say design strength of concrete is 36 to 40. 36 to 40 in first case, then 50, then 30, 30. Likewise, and minimum slump of placement, slump for placement is 7, 9, 12, 15, 12, 15, 7, depending on that. I'm not going to speak everything here, just for information. This is how we consider this. You can pause if you want to read. If you want to read this statement, you can pause your video and read this. It's not a big question, like to waste time. Another thing is average amount of reinforcing steel is value obtained by dividing amount of reinforced average amount of reinforcing steel is a value obtained by dividing amount of reinforcing steel in a section in which concrete is placed continuously by volume of concrete. So average volume of reinforcing steel is value obtained by dividing amount of reinforcing steel in a section in which concrete is placed continuously by volume of concrete. Reinforced concrete equivalent amount of reinforcing steel. Reinforced concrete equivalent amount of reinforcing steel is a reference value calculated by assuming that entire section of sheet is equivalent to reinforcing steel. Girders include the superstructure. Girders include superstructure of hollow slab bridge. Pre-stressed reinforced concrete bridges are not included in table. Since difficult to determine standard value, amount of is relatively small compared with amount of reinforcing steel. Densely reinforced regions are those where amount of reinforcing steel is particularly large. Densely reinforced regions are those where amount of reinforcing steel is particularly large, such as anchorage zones of cable stays, bridges and superstructure. When a number of concrete members can be cast separately, minimum slump of placement shall be specified for each member. It's not possible to change slumps during placement process, as when number of members are to be cast consecutively. Method of using largest of minimum slump value required for placement should be used as a standard. It's a very important paragraph. When a number of concrete members can be cast separately, minimum slump for placement shall be specified for each member. And if it's not possible to change slumps during placement process, when a number of members are to be cast consecutively, you cast, for example, you cast column, then slab, beam, all, and maybe some other sections, the walls, or we call it monolithic casting. Monolithic casting is very important. We cannot say you can use many values of slump. That's what it's saying. Method of using largest of minimum slump values required for placement should be used as standard. When a number of concrete members can be cast separately, there's no problem. You can count down to different values of slump. But when you cast combination, you count monolithic actions of various members, minimum slump of placement shall be specified for each member in case of individuality. But when you count jointly, for example, you got suspended slab with column heads and beams, the down beams or various portions of walls, and if it's not possible to change slump, you cannot change slump in that case. The replacement of process as a number of members are to be cast consecutively. Method of using largest of minimum slump values required for placement should be used, because generally in suspended slab we use less slump value, in walls we can use more value, in beams generally we use same as we use for suspended slab, and of course many times column heads and beams are cast together, while columns require not very low slump but a good slump. It's of course more than beams slump, but we use same slump as we used in suspended slab and beams for this portion of column, which is the top head. So you cannot say that there's a uniformity, but there's no other way. When concrete to be placed is pumped for on-site transportation. When concrete is to be placed is pumped for on-site transportation. Slump loss under different conditions such as pumping conditions, minimum slumps and environment conditions shall be considered, which are given here. Typical slumps under different conditions, and that's the point here. Typical, you can say typical slumps under different conditions, and that is construction condition and slump loss. Typical slumps under different conditions. Pumping distance, we have to consider equivalent horizontal distance, and we have to less than 150 meter. It's 150 meter to 300 meter. It is 300 meter to less than 500 meters, and it is 500 meter or more. So there are variations up to more than half kilometer. It's a big one. So conditions are different. We are considering first one, horizontal distance we have to consider, and when secondly we use the slump loss when minimum slump is smaller than 12 centimeter, and when minimum slump is greater than 12 centimeter. Here 120 is limit put in by this author, and we have to consider that it says less than 150 meters including placement by bucket, etc. So what it says in this case, when it is less than 150 meter distance and including placement by bucket, slump loss is not mentioned here. Now it's 150 meter to 300 meter, it is 1 centimeter. It's 300 meter to less than 500 meter, 2 centimeter to 3 centimeter, 1 centimeter. Placement bucket, and you can say 500 meter or more to be determined on basis of past project data. In this case, slump is indicated very slow because it is written including placement by bucket. And by bucket, for reference, when daily average temperature exceeds 25 degrees Celsius during summer, it is recommended that 1 centimeter be added to each values shown above. Now as the commentary says, when determining slump requirements, it is necessary to take into account not only structural conditions such as type and dimensions of member concerned. When determining slump requirements, it's necessary to take into account not only structural conditions such as type and dimensions of member concerned and arrangement of reinforcing materials, reinforcing bars and other steel, but also construction conditions such as On-site transportation methods. Type of concrete: pumping, pumping, piping direction. Concrete placement methods: drop height of each layer of concrete to be placed, and compaction methods. Type of internal vibrator spacing, insertion depth, vibration time. Basic rule is to minimize slump of concrete being placed to the extent that workability requirements can be met. It's important to carefully consider construction methods such as concrete placement methods, drop height of each layer to be placed, and compaction methods. Compaction height, type of internal vibrator spacing, insertion depth, vibration time. I repeat, this is comment but important one. When determining slump requirements, it is necessary to take into account or consideration not only structural conditions such as type and dimension of member concerned to be poured, arrangement of reinforcing materials, reinforcing bars and vessels, but also construction conditions such as on-site transportation methods. This means type of concrete pump, it is pumping distance, pumping direction, concrete placement methods, drop height of concrete, height of each concrete layer to be placed, and compaction methods, which is whether internal vibrator or spacing of vibration, insertion depth, vibration time. Basic rule is to minimize slump of concrete being placed to an extent that workability requirement can be met. It's important to carefully consider construction methods such as concrete placement method, drop height of each layer to be placed, and compaction methods. Compaction height, type of internal vibrator spacing, insertion depth, vibrator time. Slump and other properties of fresh concrete continues. Slump and other properties of concrete continued change throughout process from transportation from concrete plant to construction site. Slump and other properties of fresh concrete continue to change throughout process from transportation from construction plant to construction site, from construction plant here means batching plant to construction site, on-site transportation, placement, and compaction. So there are three stages saying slump and other properties of fresh concrete continue to change throughout process. And one is transportation from batching plant to construction location, or you can say construction site entry, then from site entry to location of more on-site transport placement, you can say, and compaction at point where you concrete. In order to achieve smooth and complete filling or pouring, it is important to make sure, in view of changes during these stages of construction work, appropriate filling ability or pourability is retained at stages of placement and compaction. Construction standards therefore first defines minimum slump necessary at time of placement and requires that a target slump be used for quality control at unloading location and a target slump upon completion of mixing production. This means placing location, then receiving location from batching plant, and then batching plant location. It says construction standards therefore first defines minimum slump necessary at time of placement and requires that a target slump be used for quality control at unloading location and a target slump upon completion of mixing production to be used for quality control at production stage be specified as criteria for minimum slump. Slump at placement, unloading and production stages determined in mix design are determined in view of occurrence of slump changes. Now we have to follow certain points here, and that is step 1, determine minimum slump or placement first of all, because that is ultimate. Determine minimum slump or placement. Select minimum slump required to fill formwork reliably, and completely according to structural conditions. such as type of member, amount of reinforcing steel, and reinforcing bar spacing, and construction conditions such as compaction height. Step 2 is determine target slump at unloading location. This was at filling place. Step number 1 of placement of concrete, and second is determination of target slump at unloading location, or you can say where we receive concrete when we enter site. So determine a target slump at unloading location on basis of minimum slump for placement in view of slump loss during on-site transportation, such as pumping, changes in slump due to passage of time during process from unloading to placement, and quality variation at production stage. As for this standard certified articles as standard procedure, quality control and acceptance inspection of concrete are performed with respect to this target slump at unloading location. Slump loss, and we can say compensation. Slump loss due to on-site transportation. Slump loss due to on-site transportation, such as pumping, is selected from given table according to construction conditions, such as pumping distance. Amount of quality variation at production stage is determined appropriately according to conditions of production equipment and quality control within allowable ranges. 2.5 centimeter for 8 to 18 centimeter slump, and 1.5 to 2 centimeter for 21 centimeter slump. And what is that? Amount of quality variation at production stage is determined appropriately according to conditions of production, equipment and quality control within allowable ranges, and that variation is 2.5 centimeter, 1.5 centimeter, 2 centimeter, and this is for 2A's. 2.5 centimeter variation for 8 to 18 centimeter or 80 to 180 centimeter slump, and 1.5 to 2 centimeter variation for 21 centimeter slump. For certain changes in slump due to passage of time during process, changes in slump due to passage of time during process from unloading to placement are estimated from past project records or data, or time dependent changes observed during trial mixing mentioned, and however decrease in slump over time during period of time necessary for construction work should be minimized, and that's important. A decrease in slump over time during period of time necessary for construction work should be minimized. It's therefore important to select mixed proportions at trial mixing stage. That makes it possible to retain required slump by, for example, using appropriate chemical admixture. These are two steps we have gone through. Step 2 is more detailed here, and determine target slump for freshly mixed concrete. And this is step number 3, and then we have, otherwise after that we'll go further on that. So we have here third step 3 we are talking now. Determine target slump for freshly mixed concrete. Target slump we have to determine for freshly mixed concrete, taking into our account decrease in slump due to off-site transportation to unloading location, whatever distance may be at point we have to place and to point where we receive this truck. A thumb rule, or there's no thumb rule, but let us say a thumb rule of about relationship between time required for transportation to construction site and slump is that amount of decrease in slump during spring and autumn is about 1 centimeter per 30 minutes. Spring and autumn is 1 centimeter, 30 minutes and a half an hour. 1 centimeter per 30 minutes of transportation. In winter, slump loss due to increase in transport time is low, and slump loss is about 1 to 1.5 centimeter per 60 minutes. So you can say it's about half you can say. In winter, it is less loss in Otherwise it is more loss, and this ratio of 1:2 can say in winter if it is 1, in 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 summer it is 2. It's like that. However, during summer hot weather, concrete shall be taken care of because slump loss over time tends to be higher, about 1.5 centimeter per 30 minutes of transportation. So what is step? Step number 1 is minimum slump for placement. Step number 2 is target slump for unloading, and step number 3 is target slump upon completion of mixing. And minimum slump for placement is given arrow and is written to be determined according to this table on basis of conditions such as type of member, amount of reinforcing steel and reinforcing bar, spacing, and there's a dotted box here, variability during production process from unloading to placement, and amount of decrease in slump due to non-site transportation allowed for. And the second one is target slump for unloading, value obtained by adding amount of decrease in slump due to on-site transportation from unloading location to placement location, and a slump tolerance at unloading location to minimum slump for placement. In this case, dotted box is amount of decrease in slump due to transportation from an off-site plant to unloading location at construction site allowed for target slump for unloading, and target slump upon completion of mixing, value obtained by adding slump loss due to transportation from on-site plant or off-site transportation from ready-mix concrete plant to target slump for unloading, and that's target slump upon completion of mixing. So you can see these downloads are flow of slump determination, and movement of concrete you can select this. Flow of slump determination and then movement of concrete, flow chart for slump determination, different stages. And then you can see in mixed design, it's a basic rule. In mixed design, its basic rule to secure. I must also show my batteries. H90. Okay. In mixed design, its basic rule to secure required minimum slump. In mixed design, it is basic rule to secure required minimum slump for placement so as to achieve good filling ability. If, however, a large amount of decrease in slump is expected because construction tasks such as transportation to construction site and a series of tasks from unloading to placement are time consuming, or if slump loss due to pumping is expected, it may be necessary to set a target slump at unloading location or upon completion of mixing that is larger than target slump. In such cases, simply increasing slump at unloading location or upon completion of mixing might cause segregation during production or off-site transportation, resulting in not only quality control and acceptance inspection problems at unloading location but also clogging of piping during pumping. In order to prevent these problems, mix proportions may be adjusted so that concrete has good workability at target slump at unloading location. Same mix design procedure may be used in cases where ready-mix concrete is used. As first step, minimum slump for placement is determined and target slump upon unloading is determined so that minimum slump for placement can be achieved. Target slump upon unloading is used as specified slump. For ready-mix concrete, a simple method for specifying this target slump upon unloading is certified items described in recommendations. Now, standard specification of concrete structures 2010. Now what is this? You can say this changes in slump over time at different changes of construction. Changes the three figures here. In first case, slump, again slumps the same, and it says here that step 1, and it is minimum on this, you can say minimum slump for placement, that is slump and duration in terms of work. So you can say completion of mixing. Here is completion of mixing from batching plant. It goes to transportation. It goes to then transportation to construction site, and here is unloading. What my point? This is completion of mixing at batching plant. It's transportation to construction site and unloading. And then start of pumping is here, and on-site transportation, pumping, and placement here. So these lines you can say stages, and this is you can say duration in terms of work, and that is step 1. It is minimum slump for placement and goes upwards. The other one is step 2. Here is completion of mixing, then transportation to site, unloading, then on-site transportation here, and duration in terms of work. Same lines but expanded one, and here is quality variation. You can see it is start of pumping to placement, and there can be this reference. So you can say one arrow down is quality tolerance. Other one is slump loss over time, and then slump loss due to on-site transportation. 3 slumps are given, and that's other one is slump, and that's step 3. Here is you can say the same thing as target slump was here. In that case there was no target slump here. Here's target slump, in this case is here, and here is another one. This target slump upon completion of mixing, target slump at unloading, and then you can say here is this one. Same way, and you can say same here, except this is increased here. Step 3 are same, this graphical form. In order to construct a highly durable and densely cast concrete structure, here it said that in order to construct a highly durable and densely cast concrete structure, or it said is here, I think frame rate is low. Is it 13 fps? I think it may fall. I don't know what will happen. Let me do my way. I don't know. In order to construct a highly durable and densely cast concrete structure, it's necessary to provide concrete with workability suitable for structural conditions. In order to construct a highly durable and densely cast concrete structure, it is necessary to provide concrete with workability suitable for structural conditions. Construction standards show typical values. Construction standards show typical values of minimum slump for placement suitable for structural conditions for different types of structure. Now it says there's some figure which shows, table shows typical minimum slumps needed at placing location for different types of structural members, determined on basis of past construction experience, on condition that standard construction methods are practiced. From this table, standard values of minimum slump for placement can be selected according to structural conditions. Standard construction methods specified in construction standards of specification. First is task category, other column is item, and then standard method. Task category is transportation, placement, and compaction, 3 categories as we discussed before. An item is transportation to construction site and on-site transportation. In transportation to construction site, it is agitator of transit mixer itself, and on-site transportation is concrete pump. On-site transport. Then in placement, it is dropping height within 1.5 meter, and placing height per layer is 40 to 50 centimeter. Placing height per layer is 40 to 50 centimeter. Allowable placing interval. Allowable placing interval is outdoor air temperature is 25 degrees Celsius or below and 2.5 hours. Standard method. Outdoor air temperature higher than 25 degrees Celsius, 2 hours. So if it is 25 or below, it is 2.5 hours, and if it is 25 degrees Celsius or above, it is 2 hours. Compaction. Compaction method. Internal vibrator and vibrator spacing about 50 centimeters. Vibrator depth about 10 centimeter in underlying layer of concrete, means interlocking between two layers. Vibration time per point 5 to 15 seconds. It's very important information. I repeat, transportation category, transportation to construction site, agitator use, and on-site transportation, concrete pump. Placement is topping height 1.5 meter, not more than that. Placing height per layer is 40 to 50 or 400 to 500 mm or 40 to 50 centimeter. As usually we take. Allowable placement interval, outdoor temperature 25 degrees 2.5 hours, outdoor temperature above 25 degrees 2 hours. Compaction, in compaction method, internal vibrator spacing about 50 centimeter, vibrator depth about 10 centimeter in underlying layer of concrete or interlocking. Vibration time per point is 5 to 15 seconds. In construction, construction standards, compaction height, which is related to degree of ease or difficulty of compaction, and placing height, which is a widely used term, are distinguished. Compaction height is defined. You can say this is compaction height. You can say here we are doing this. So this is compaction height. Where point this is compaction where a person stands and we compact, and this is compaction height here. Here that's the difference here. This is compaction height. And this is previously placed concrete, and this is new concrete here. And here is that's what it says. Of course, you can see other one here, and this is also compaction height here. You can see this compaction height, and here is also previously placed there, and this is compaction height. So examples of compaction height is shown. This is compaction height, means new concrete. This in construction high standards. Now it's related to the degree of ease or difficulty of compaction, and that is in placing height, which is a widely used term, are distinguished. Compaction height is defined as height from working platform which construction worker stands to lower end of formwork or upper surface of previously cast concrete layer. If concrete is placed continuously and compaction is performed while moving upwards, as height of newly placed concrete increases, distance from moved working platform to surface of previously placed concrete is compaction distance. Minimum slump for placement is determined for each type of member. Use of different types of concrete mixes with different slumps. However, when different types of members such as columns, beams, walls and slabs are cast continuously, would make construction work and management cumbersome and lower construction efficiency. Use of different types of concrete mixes with different slumps, however, when different types of members such as columns, beams, walls and slabs are cast continuously, would make construction work and management cumbersome and lower construction efficiency. A rational approach in such cases is to select concrete mixes suitable for members that are relatively difficult to construct and require relatively large minimum slumps for placement. It's important, however, to carefully consider in advance whether problems can be prevented by modifying concrete related arrangements such as concrete placement and compaction methods. I repeat, minimum slump for placement is determined for each type of member. Use of different types of concrete mixes with different slumps. However, when different types of members such as columns, beams, walls and slabs are cast continuously, would make construction work and management cumbersome and lower construction efficiency. A rational approach in such cases is to select concrete mixes suitable for members that are relatively difficult to construct and require relatively large minimum slumps for placement. It's important, however, to carefully consider in advance whether problems can be prevented by modifying concreting arrangements such as concrete placement and compaction methods. In order to keep performance of fresh concrete necessary for placement, it is necessary It is essential to predict changes in concrete quality due to influence of pumping conditions and environmental temperature. Allow for such changes in determining slump requirements. Typical changes in slump corresponding to different construction conditions such as pumping conditions are, and if relevant information such as past construction records and pumping target results available, slump requirements should be determined on basis of such information. Required strength of concrete is determined in view of specified strength and variability of concrete quality at construction site. Required strength CR of concrete is determined so that possibility that a measured value of compressive strength of concrete obtained as on site test results is a smaller value of compressive strength of concrete obtained as on site test results is smaller than specified strength 5% or less. Required strength of concrete is determined in views of specified strength and variability of concrete quality at construction site. Required strength of the CR of concrete is determined so that probability is that a measured value of compressive strength of concrete obtained as on site test results is smaller than specified strength. Commentary. Usually quality of concrete let's suppose this then we can have this can read this for time being. Read this for time being. It's important for you. Commentaries, I'll be back in 5 minutes. Will you please allow me that? It's for sure it is. We have to see this. 5 minutes I'll be back. I can say. I'll be back in 5 minutes. Let me see. हाँ जी. So I was talking about commentary, and we have to come to commentary. Usually, quality of concrete at a construction site varies during construction period, depending on such factors as changes in quality, aggregate, cement, etc. It says that usually quality of concrete construction site varies during construction period depending on such factors as changes in quality of aggregate, cement, etc. Measuring errors and changes in the way concrete ingredients are mixed. Required strength of concrete, therefore, needs to be made higher than specified strength according to variability of concrete quality at construction site. In order to ensure that compressive strength of concrete in any part of structure is not lower than compressive strength assumed when designing structure. Required strength of concrete needed relative to specified strength is usually determined in accordance with conditions. This clause describes compressive strength requirement for test specimen to be used to achieve specified strength of concrete. Inevitably measured values of compressive strength of concrete vary to some extent depending on changes in quality of cement, aggregate, etc. Measuring errors, differences, conditions under which mixing and other tasks are performed, test errors, etc. It is known from experience that variation in compressive strength of concrete under ordinary quality control conditions are more or less distributed normally, assuming a stochastic distribution. Therefore, this guideline requires the probability that a measured value of compressive strength of concrete used for an ordinary structure is smaller than specified strength, be 5% or less. A measured value of compressive strength of concrete obtained as an on-site test results of average value of compressive strength obtained through standard curing of 3 concrete specimen. Okay, we'll take care of this next time now. I think we have to close here.